Hey guys, in the previous lesson we looked at the inverse rule. So in this lesson we're going to be looking at rule number 5, the power to power rule, or simply I call it the product rule, okay, when working with exponents or indices. Now here it states, if a base raised to a power is all raised to another power, you must multiply the powers, okay? And I just try to make it as simple as possible. For example, here we have a base a raised to a power m, and if you notice, all of that is in bracket and all of that is raised to the power n. And as you see here, we just simply rewrite our base a and we just simply multiply out the powers, okay? Now let's look at a quick example to just reinforce the point. Let's say in example number 1, let's say we had 2 raised to the power of 3, and that is all raised to the power of 2. Okay, my friends? Now, really, my friends, what this is saying, this would imply that I have my base 2, this big 2 here, let me change the color. I have my base 2 there, and I am simply saying I am going to multiply the powers. So 3 multiplied by the power 2, okay? And this is really base 2 raised to the power of 3 times 2, that would give us a 6, which essentially is 2 to the 6. We know that's 64. Okay, my friends? That's 64, and that would be our answer. Okay, that would be our answer. Now, yes, this is what the rule says. Now, let's just look at the whole concept behind it, because by now you should know that I just don't like to just stick to rules. It makes sense when you understand the concepts, because even if you forget the rule, the concepts will remain. Okay. Now, let's take the same exercise. So I'm going to say 2 to the third, close bracket. Okay, and that's all raised to the second power. Now, my friends, if you should think about it, okay, if you should think about the general concept, what this is really saying, this is really saying I have 2 sets of 2 to the third. Remember, if you remember from basics, what the power outside is telling you is how many times the base is being represented. And in this case, since the 2 is this 2 outside here would be the dominant power. So what this is really saying is that I have a 2 to the 3 multiplying itself 2 times. So this implies really that I have a 2 to the third power, okay? And that is multiplying another 2 to the third power. Okay, my friends? That is simply what this is saying. Now, we could just break this down a little bit. Now, if you notice, my friends, I can just say this implies that I have a 2 raised to the base 3. This is simply saying, my friends, I have a 2 multiplying itself 3 times. So this is saying I have a 2 times 2 times 2. And I'm just going to close my bracket. Let me just change my color. Okay, let's change my color and let's use another color over here. Now I'm just going to simply say this green multiplication sign represents this white one in the middle, this white multiplication sign there, and I have another 2 to the 3 there. So I'm just saying this is 2 times 2 times 2, okay? And I'm just simply going to close my bracket there. Now what this implies that, if you notice here, I have a common base 2. I have a base 2 that is common, so I'm just going to rewrite back my common base 2. And if you notice, let's just count the amount of 2's that we do have. We have 1, 2, 3, 4, 5, 6. So we have 6 2's. So if you notice there, I still got back a 2 to the 6 and a 2 to the 6, my friends. As you can see it here, 2 times 2, that's 4. 4 times 2, this would be 8. 8 times 2, that would be 16. 16 times 2, that would be 32. And 32 times 2, that would be 64. Okay, so that's the same as 64, and that would be our answer. Okay, so I mean, this is the general concept, this is the idea behind it. So it's nice to have the idea, because sometimes under exam pressure you may forget what to do. Let's just quickly look at another example before we close. Let's just split the screen there. Now, since you have gotten the general idea of what is happening, let's just quickly run through a few more. Let's say in item number 2, let's say they gave us 3 raised to the power of 9, and I'll have that in a bracket, and that is all raised to the 1/3, a fraction. Okay, now really that would imply that I have a base 3 And since the power here is 9, I'm going to take my 9 and I'm going to just simply multiply it by the next power, which is 1/3. Now I know that 3 into itself goes once, 3 into 9 goes 3 times, okay? So this implies then that I have a 3 to the third left over. And we know that 3 to the third, okay, let's just take it down here a bit. We know that 3 to the third is the same as 3, let's change the color, is the same as 3 times 3 times 3. And 3 threes will give us 9, and 9 times 3, that will give us a 27 rather. Okay, so 27 is our answer. Okay, so it's pretty much that easy. Let's just quickly look at another exercise before we leave. Okay. Just to reinforce the concepts, I like to know when my guys are very comfortable with these topics, okay? So no matter how the examiners may set the questions, you already have a strong grasp of what is happening. Let's say in the exam you went in and you see on your exam paper you had 5 to the 4, and that was all raised. And let's just raise this. That's all raised to the negative 3 upon 2, okay, my friends? Now, really, what this is saying simply, again, guys, this is just simply saying I have a 5, base 5, and I'm just going to multiply my powers. I'm multiplying the 4 multiplied times my negative 3 upon 2. I know 2 into itself goes once, 2 into 4 goes 2 times, okay? So really what I'm left with here, I'm really left with a 5, my base 5, so let's just rewrite the base 5, and I'm left with 2 times negative 3, and that would give me a negative 6, okay? Now, based on what we learned from the previous video, and I don't really have to go back through that, hopefully. If you're not sure, you could just always revisit the previous video in the playlist. Rule number 4, the inverse rule. Remember, we said that if you have a base raised to a negative power, simply we can just place 1 upon the base or just flip it, and we get the power to be positive. Okay, so I would have a 5 to the 6 there, and we all know now that this is the same as 1 all upon 5 times 5 times 5 times 5 times 5 times 5. Okay, how many 5s? 1, 2, 3, 4, 5, 6. Okay, and that can be easily calculated. So let's just quickly bring up our calculator. Okay, so here's our calculator. So basically what we have a base 5. So I'm just going to plug in 5, and I'm going to simply raise my 5. Let's just raise 5. If you notice, a little arrowhead is there, to the 6th power. Okay, to the 6th power, and that is equal to 15,625. Okay, so what we really have here, my friends, is 15,000. So this implies that we have a 1 upon 15,625, and that would be our answer. Okay, now this is our answer. Okay, when that is multiplied out. Let's just look at a final example before we leave, just to reinforce the whole concept. Let's just pull this up a bit quickly. Let's say in this example now, in this exercise, we were given, oops, let me change this. And this is number 4, okay? This is example number 4. Let's say they gave us a base 2, a raised to the power of 2, and then we had a b raised to the power of 5, and then we had a c there. Okay, and this is all in bracket. Let's just put all of this in bracket, and we're raising all of that to a positive 3. Okay, let's just quickly look at this to see what would happen. Now, remember, my friends, we're going to take each element. First, I'm going to start with the number. If you notice, I have a 2 here, but remember, this would be 2 to the power of 1. Okay, can't forget that now. That's very important. So really what I'm saying 2 raised to the power of 1, and my 3 that is outside here, because everything is bracketed, then the 3 is going to have an effect on each element inside the bracket. Okay, so I'm going to have to say this 1 times my 3, and then I'm going to have to say my a rather. I'm going to have to take my a, and a was squared, so I have to square that, and then I have to multiply it by my 3 also. Okay, and then I'm going to have to take my b now, So let's quickly take our b, and my b was raised to the 5th power, okay? And then the 3 is also affecting the b, so I'm going to have to multiply that by 3 also. And then, my friends, finally, I'll have to take my c, okay? And my c, if you note again, my c is raised to the 1st power, okay? Because if you don't see a power, remember the first video when we were introducing indices or exponents, we said that if you don't see a power, you should always put a 1 there. So this would be 1 times 3, okay? Now, let's just quickly simplify this. We can say now then that this is really 1 times 3 is 3. So we have a 2 to the 3rd power. Then we would have an a, 2 times 3, a to the 6. And then we would have a b to the 5 times 3 is 15. Then we would have a c to the 1 times 3, and that's 3. Okay? Now, here basically, my friends, what we have left over here is really 2 to the 3 is the same as 2 times 2 times 2, okay? So really, and then we would be multiplying all of that by a to the 6, b to the 15, I'm just rewriting back these down here, and c to the 3rd. Now 2 times 2, that's 4, and 4 2s, that would give us an 8, okay? So essentially what we have here for our answer, my friends, all of this would work out to be 8, okay? A to the 6, b to the 15, okay, and c to the 3rd, okay, and that would be our answer. Hope that this was useful. Feel free to leave a comment if you're still not sure, or ask a question, and we'll get back to you as soon as possible. Okay, bye bye.